Very good morning to everyone. Thank you for spending the next 1 hour of your time with us. Our today's topic is actually a very interesting one. This is actually part of the real E&E engineering series, where we intend to guide you through, because you guys are SPM leavers and maybe STPM leavers, so we want to let you know what are the actual job prospects, the industry demand, the real applications, and the current engineering trends in E&E engineering series. So the E&E stands for electrical and electronic, but over the next 1 hour, our focus will be on the big E, which is electrical engineering. Now, electrical engineers, they are very versatile. They are needed in many different fields and areas. But today we are only going to focus on one of it, and it is also a very exciting field, right? Namely in the renewable energy field. And then we will move on to talk about what is it like to be an energy manager, right? To most of you, maybe this is the first time that you are hearing this word, but fret not. We have a very renowned speaker today with us today right here, right now, Prof. Kannan. So please allow me to briefly introduce, right, our distinguished professor today. So Prof. Kannan is actually the Professor Emeritus from UTM, currently attached to ISI Ventures UTM. So he is a professional engineer registered with the Board of Engineers Malaysia and a chartered engineer registered with the Engineering Council UK. He is a fellow of IEM Malaysia, IMECI UK, and ASHRAE USA. He's currently a local energy consultant and trainer and has more than 30 years of experience in energy research and consultancy, including collaboration with international energy organizations. His expertise is in energy efficiency practices and technologies. He has served as the National Project Manager for the UNIDO GEF project on industrial energy efficiency for Malaysian manufacturing sector from December 2011 to April 2017. And now he is wearing the hat of the technical advisor for UNIDO in Malaysia. So Professor Kannan, I understand that you have a few slides to maybe walk us through. So the floor is yours, Prof. Kannan.
Yeah, I thought I just set the scenario so that we can continue further. Let's see if I can upload. Shall I present now?
Prof. Kannan, you may share your screen.
Yeah, all right. Can you see?
Not yet.
No.
Yep, not yet.
Oh. What has gone wrong?
You can try to click present and then your entire screen.
I've already put that, and
you have to select your screen. Yeah.
All right, now I put the slide. Is it okay now?
No, we are not seeing it.
How do I go back? Huh? Oh, I think share.
Yeah, share.
Present, entire screen.
Yep.
Share.
Maybe the other option is you can also
share here.
Yeah, or you can also send the slides to us, then we can project the slides as well.
So I forward it to whom?
You can reply to the email.
Yeah, this. Okay, I forward. Huh?
Okay.
Okay, I've sent it. I sent it to your mail.
Okay, we are waiting for it. Maybe while waiting for the slides
Okay,
to
all right,
yeah.
we can do that. Okay.
Okay. Still yet to receive a slide. So maybe while waiting for it, maybe
Okay, all right.
Afan,
Yeah.
maybe we can
Sure,
start
you can start off.
with a little chat, right?
Yeah.
Because today's our focus is on energy management, right? So,
Sure. Okay.
So maybe, Prof, you can walk us through like what is actually the word energy management? What is it actually?
Energy management actually is a very broad term, but basically it is the way to contain the energy, to manage the energy in such a way that we can use the energy output from the equipment or appliance and all effectively and efficiently. Right? So, in order, if you go to like in an industry, right, you see that there are so many uh, equipment and so many processes and so on, and you do need a good policy or a good understanding of the how it works so that you can manage it efficiently. And for this, it always starts from the commitment of the top management. That means the top management must agree that yes, we want to use energy efficiently, we want to manage our energy, and we also want to use the sort of latest technologies in the energy. Now, so to do that, he needs to sort of appoint a person, of course, in charge, who is actually known as the energy manager. And the energy manager can, of course, set up a team. And then they have to look at the various aspects of energy consumption in the factory, in the industry, and try to find methods to improve it or to sort of better it or to even change the sources of energy and so on. So that is energy management. It is very wide, but it is effective because we want to, once we do a certain thing in the energy management, we want it to be sustainable, right? And for it to be sustainable, we need a good team of people to do this energy management in industry. Of course, it also applies in buildings, but in buildings, it's much less complicated because there are no processes. It only works on air conditioning and lighting.
Okay, Prof, you mentioned a very big word there, sustainable. So
Yeah.
maybe you can walk us through like what do you understand by the term sustainable?
Sustainable means that if you do a certain thing, or for example, your sources of energy should be like available to you at any time. Right? We need the sources of energy because we need to our activities to carry on. So we shouldn't be sort of in a position where we are like cannot do, we cannot carry on. So if not this, then we have another alternative, alternative B or plan B. And we have to ensure that there's no interruption in the activities or no interruption in the supply of energy and no interruption in the progress towards what we want to achieve. That means our output is always there. So that is sustainable, and that sustainable basically also comes from the energy sources.
Mm.
We now have, of course, we use the fossil fuels. In fact, we have to use fossil fuels for a very long time because that is what is available to us. But we always know that these fossil fuels have a limited time life. It is not like cannot be used forever, and so therefore we need to have some standby. And one of the standby is, of course, this renewable energy, which is still very, what shall I say, lowly used. We have not come to the uh, abundant use of renewable energy, but we are slowly going towards that. But for this, we need the people to know what are the sources of energy which are sustainable, and one of it is renewable energy.
Okay, and that leads probably us to the next discussion here is on,
Yeah.
you mentioned the word renewable energy, and you mentioned that preferably the energy resources has to be replenishable. They are naturally available on human time scale. So
That's right.
So
Yeah.
so perhaps you can give us some examples of the renewable energy sources out there.
Yeah.
That we can tap into. Yeah.
Actually, renewable energy covers quite a broad field. And the main field, of course, is the solar energy, because these energy are the ones which occur naturally. We have solar, then we have hydro. Right? Hydro is also, now it's classified as renewable. It was not formerly, only the small micro hydro was classified as renewable, but now hydro is classified as renewable. And then you have the waste. And when you say waste, it includes things like biomass and biogas and so on, right? Which all comes under one. And we have wind energy, right? Which is also there, naturally is there. And if we look at all these things, we find that in Malaysia, in our country, the main available energy is solar and also hydro. Right? Biomass or biogas is there, but somehow it's a bit expensive to use, a bit expensive, and also it is requires much more technical knowledge to use biomass. So solar is one, and of course then the hydro. And we always have biomass as standby, which can be used.
Yeah, I think Prof, you brought a very important point just now. You mentioned that hydro used to be not considered a renewable energy. Maybe you can elaborate on that. Yeah, I don't think many of us know about this. Yeah.
Yeah. Actually, in the terms of hydro, we see that whenever we sort of try to implement hydro, right, it always has what shall I say, negative impact on the environment. So this is important because when I use the word sustainable, when we do a lot of hydro projects and all that, we find that we have to do a lot of dislocation of people and also the natural habitat and so on. And so therefore it's not considered environment friendly. Right? But we also have these small ones, small they call it the micro hydro or the mini hydro, which is feasible and it is used like an alternative to maybe electricity or something. So that is what we meant. But now, in the terms of renewable energy, it has been redefined, and they've included hydro. That's why in our country now we can say that we have a good percentage of renewable energy because we have already included hydro into our formula. So therefore, we have about nearly 20% of renewable energy. This is because of hydro, if not because of that. And our hydro is mainly in the East Malaysia, and as we know about that.
Yeah, I think that is a very important insight. I think for someone who has probably just completed SPM, maybe maybe they heard of hydro, but mini hydro and micro hydro is really something that you guys can explore further. Okay. Speaking of which, I think we can move on to like some of the advantages of renewable energy. I think Prof, you have already mentioned some, which is it is friendly towards the environment and all that. But in terms of to the people, right? In terms of job creation, does renewable energy, plays a role in this?
Um, it does because renewable energy, although we say is available naturally, but it needs some technical knowledge and all to sort of put it into place. So therefore, we need that people, the people to sort of generate it, and by generating, I mean install it in such a way that you can maximize from it. So although it is considered, I mean, many consider it as a free energy, right? Because it's available abundantly, and also, but you find that it really is. It has to be uh, used, or it has to be realized in a better way so that we can maximize the use. And we always say that you want to use renewable energy, we have to make sure that all our systems are efficient. Right? Once they are efficient, then we can maximize the use of renewable energy. And so for this one, we need the people who are conversant with the, one is of course energy efficiency as such. Then the other is the technologies where we can enhance or use the renewable energy. And we also have to bear in mind that renewable energy can never replace the fossil fuels, because renewable energy is not that, what can I say, reliable. We see that, of course, when we say solar, the sun, we see that sometimes you have the bright sun, sometimes you have the sun which is blocked by clouds, you have the diffuse radiation from the sun, and so on. So there is a lot of need for people to sort of maximize the use of renewable energy. And this is where engineers come in. Engineers come into the play, because engineers must understand how they are going to get the renewable energy into use.
Yeah, I think Prof, you again a few pertinent points here. I think um, what Prof is trying to say is that energy, I mean, it is everywhere, but for us human to be able to make use of it, the energy has to be converted to some form, right?
That's
And
right.
and and usually, I think most of the energy that we can conveniently use is in the form of electrical energy, right?
Yeah.
So the process of converting the energy, right, from the widely available from nature to something that we can, like our laptop now is being powered by electrical energy. So perhaps the source can be from solar, can be from wind, but still we need the expertise to be able to do all these things to ensure that the energy is generated and delivered to us. So I think
Yeah.
that would be one of the key
I,
points.
I think if you look at the solar energy, for example, because that is the one which is most abundant, uh, if you really want to extract the solar energy using the PV cells, the photovoltaic cells, you find that the efficiency of the photovoltaic is only, I think maximum is now about 18%. Right? So again, you have the conversion. That means from the energy available from the solar, in this case, it is the light energy, only 18% is actually usable or can be utilized in the actual. And so there is this work also of development of the solar PV cells. That is still under big research, and it's going on. I mean, it's a global thing. It's not only in Malaysia. It's a global thing. So we need to find ways to convert the solar energy into electricity, which is what we're talking about. Right? And so if we use solar energy, we have to use, say, a big area of where we put our panels to generate that solar energy. I mean, so that electrical energy we need. right? And this is these are the problems are faced by actually using the solar.
Yeah, I think, Prof, I think something which is also linked to the point is that because the people think that because just now you mentioned about the word energy efficiency, people always think that okay, so we want to have a more sustainable world, so the energy has to be sustainable, so we should focus just on the putting up more solar panels, putting up more windmills, but I think the answer is also on the energy efficiency side as well of things.
Yeah, sure.
So maybe, Prof, you can elaborate further, like what is the meaning of energy efficiency? I think people get confused.
For example, if we have, I mean, let's talk about an office building, right? In office building, the main energy consumers are the air conditioning and also the lighting, right? These are the main things. Now, if you want to use solar energy or solar PV as one additional energy source, we see that that can be converted into electricity. But if your lights are, say, if you're using the fluorescent lights, and if you're using the like T8 type of thing and all that, you find that if you replace the lights by the actual LED lights are much more efficient. Right? They give the same output. You're able to do what you want with the LED lighting, but they consume less power. And this less power can be actually obtained by the solar PV. Right? So instead of the light consuming about, say, 36 to 40 watts, you just need 5 to 10 watts from the renewable energy to support your lighting. So that's why I say if you use efficient lights, right, in the building, or you practice energy efficiency, then you find that you do not need that much of renewable energy, but you need less renewable energy to make sure that you get your lighting. Now, we're not here to say that solar PV is cheap. Solar PV is still expensive, but the price has come down a lot. But that solar energy, although it is, we always say it's free, but when you try to use it as PV and then bring it down, it has a cost, right? And when we analyzed in the beginning, we found that that cost is actually much higher than the cost where we use the general electricity, where we just turn on the switch and we get the electricity. So here we have that, we have the energy, we trap it on the panel, then we have to use an inverter to change it from the DC to the AC and to transfer it to our house. So solar energy as such, or solar PV as such, we need to use as minimum as possible, but to help us to use it widely in our building. So that's why we say that your building should be energy efficient equipment, energy efficiency air conditioning, energy efficiency lighting, and so on, so that the energy from the solar PV is actually a big percentage of your energy consumption. So in that way, practicing energy efficiency before using renewable energy is always recommended. And you need to use good, I mean, if you are seeing a building or residential and appliances, electrical appliances, and for electrical appliances, you have to, now we know that electrical appliances also come in various gradings or ratings. So if it is a 5-star rating, the appliance consumes less energy. If it is a 2-star, more energy, and so on. So that is what generally we want to emphasize here.
Yeah, and I think, Prof, I believe many of us are also a bit confused between energy efficient and energy saving, right? I think there is quite a big difference there actually, but maybe, Prof, you can explain further in a layman's term.
Yeah. Now, we need to use energy. There's no concern about that. But what we say is we want to use it efficiently. And to use it efficiently, we need the equipment or appliance which is energy efficient. So if you want to save energy, you use energy efficient appliances. So if you use energy efficient appliances, then you use it's the same for the same output. It's less amount of energy that you're going to use because of the appliances of good efficient. Now, energy efficiency is actually attached to the technology or to the appliance which you're using, whereas saving energy is the result of that. So if you use energy efficient appliances, you can save energy. So initially, I think before a few years back, we used to use the term energy conservation. Right? Now, energy conservation actually means you don't use the energy. So we don't encourage that. That means, for example, in your rooms and all that, let us not say that we don't use air conditioning or don't use electricity and so on, because that, of course, is already energy saving. But no, we need the lighting, we need the air conditioning. So we do use the efficient appliances to obtain what we want. That means our comfort, our productivity must be maintained. So in that essence, we use energy efficient equipments, we practice energy efficiency. At the same time, of course, we save energy, which means that we pay less for the energy. But we do not say that don't use energy, because that is the wrong way. Especially, I think if you look even in your homes, and people say switch off all the lights and so on, but it's very not a practical solution because it can harm people. Safety is also important. So in terms of safety, I think we need to actually have a good energy, good lighting, good air conditioning, and so on.
Yeah, I think that is very aptly described actually, because I mean, now especially in Malaysia, in kind of climate that we have here, the weather is so hot. Definitely, we need the air conditioning.
Yeah, we need. Yeah, correct.
Yeah, so do not confuse that. Okay, I want to be energy efficient, so I don't on my aircon. No lah. So I think what Prof. Karnan is trying to say here is we can save energy, but we can also do it by not sacrificing our comfort, and also we can still perform our daily tasks.
Yeah, productivity lah.
Yeah, productivity and safety, of course. Yeah, and I think, Prof, you also mentioned one very interesting point here is that you say solar energy is freely available, but for it to really put into practical and good use, you need to erect the solar panels, and then you need to lay the cables and all that. So definitely there will be a cost attached to it. What I understood is that I might be wrong. In the US, the cost can go up to like $3 per watts or something. It varies from one state to another. So Prof, do you have any idea what sort of costs in Malaysia?
Yeah.
Any idea?
Actually, in Malaysia, we go by the cost of the kilowatt peak. We call it kilowatt peak. Mm-hmm. So for a kilowatt peak, it used to be about 12 to 15,000 ringgit. But now the prices have come down to 4,000 or 5,000 ringgit per kilowatt peak. And 1 kilowatt peak is actually the maximum you can obtain from that amount of solar panel. Now, the erection of the solar panel, of course, the first thing you need space. Right? So that's why we put it on the rooftop, because nobody wants that space. So it's okay, you can use that. But if you want to use that to generate electricity, then we need a very large area. Right? And nowadays, land area is very difficult to come by. Right? So therefore, then we have to put it on elevated. We have to put it elevated so that we can still use the ground level. And this is where, again, the engineers come in. Engineers come in to sort of erect the panels, and then put each panel has to be put separately and then interconnected and so on, and then sent to a certain central grid from where we can draw the power. So that is, that is as far as the PV is concerned. Solar thermal also is used. The heat from the sun. That I think many of us will be familiar with the solar water heaters, which some people have in the house. Now, solar water heater is again expensive. It's expensive, but the only thing is that we use this solar water heater only for a fraction of a time. Right? In the day, especially for like having a warm bath, or some use it for washing utensils and so on. Right? So, but solar thermal actually is a higher efficiency. You can go up to about 60-70% efficiency heat from the sun. But that is much more complicated because it requires like tubes where you have to take the your water through the tubes, right? And then heat it by the sun. So those are the things which engineers are involved in. They have to ensure that they have these technologies to extract the heat or the electricity. Now, similarly for biomass again, it used to be free because it was considered waste. Right? Oh, waste in all the palm oil estates we can take it. But because it was used to generate electricity, now there's a cost to this waste, and they charge. But it requires a lot of technology to convert that biomass waste into useful energy. Because biomass waste or any other waste, you see that it contains a lot of moisture, water moisture. Moisture means water content. And we have to get rid of that water content and then dry it and then use it. So these technologies are the one which, so because of that, biomass becomes a very expensive technology to use. And therefore, it's quite limited use in our country.
Yeah, I believe, Prof, you quoted a figure that currently renewable energy usage is it contributes to maybe about 20% of the total energy that we consume. Yeah. So from 20% to scale up to 100%. So what would be the barriers? I think you have already rightfully mentioned. One of it is definitely the cost. Yeah. And the other is also the technology. So maybe, Prof, you can further deliberate on this. What stops us from going, beyond 20%, 30, 40, 50?
Of course, the main barrier which was there was the energy cost. The energy cost from fossil fuels was low, but now that is increasing. Now you see that the oil price has gone from $30 per barrel to about 100 to 150. So therefore, that is actually advantageous for renewable energy, because the high cost of the energy from the fossil fuels, then renewable energy becomes more feasible, right? And then, of course, the next is the technologies. And technologies are still being, improved. This is where we need researchers to look into the ways where we can expand maximize the use from the solar energy. And so therefore, that barrier is slowly becoming getting rid of, but it is still slow because there are not many people working on these technologies, because so far the other energy what we have been getting is relatively cheap, we say, but we know that in certain period it's going to become difficult to rely on fossil fuels. It's going to be expensive. Fossil fuels also, the prices are going up, and so therefore the renewable energy has to come into play. I think we'll also realize that this by using even like vehicles are the ones which are using the fossil fuels to quite a high extent, to a very large amount of fossil fuels are being burned away in the like transportation, and that is where we are changing it into electrical vehicles and also solar powered vehicles and so on. But it takes time. It takes time, and it, not to say that it's not feasible. It is feasible, but we need that mass. We need that mass amount of energy from the renewables which can be generated, and for that is basically is technology, and we are moving towards it. But I think so. What we have to do is at the same time, as I said, we want to use more renewables, but at the same time, we try to use our energy efficiently. And so this, once we do that, then we can see that the proportion of renewable energy goes up in our utilization.
Yeah, Prof. And I think you very good points raised there, and I think couple of times already we noticed that Prof, you mentioned that engineers have a very important role to play in this area of driving, pushing renewable energy forward, as well as the energy efficiency measures and technology. So now let's focus on so if I'm an engineer, and let's say if I'm an electrical engineer and I want to like sort of do you think if as an electrical engineer, I would have the edge in terms of prospering in this renewable energy era?
I still, I mean, my personal view is that still there's a lot of things to be done in this energy field, right? A lot of things to be done. And many industries as well as organizations are now moving towards, firstly, to reduce their energy consumption. To reduce their energy consumption means to, of course, reduce their bills. I mean, they are more interested in looking at the reduction in their bills. And so they are moving away, trying to move away from the fossil fuels. But what we can say here is that the renewable energy takes a long time to actually completely replace the conventional fuels. But as I mentioned before, that if you actually reduce your energy consumption by being more efficient, then you find that you can use renewable energy to a further extent. Right? That means you can stretch the use of renewable energy. So solar PV is, of course, the technology which has to be promoted. And in this solar PV, I think there are a lot of avenues for electrical engineers to get involved, and also to do research. I mean, I'm not very familiar with the solar PV cells, but they require a lot of electronics and so on to sort of improve their efficiency. So we need to improve the efficiency of these solar cells. I mean, it is being done continuously, but we should go really up to about 30% efficiency of this from the current 18 or about 20% to 30%. Then we find that, and for all this, you need what shall I say, a big mass, a critical mass of people working on it, right, to really improve it. And at the same time, these so-called electrical engineers can work in the industries and organizations to see how they can cut the usage of energy. Again, when I say cut, means not completely take it off. Cut means to reduce or make it more efficient, and then bring in the energy from solar. Now, always we say solar because biomass actually is still very low usage. Biomass can only be used in your own mills. That means you have a plantation, oil palm plantation. Then you use your waste, generate electricity, and use it there. But to use biomass as a central unit to generate electricity is still far-fetched for now. But it has to come in the future. Hydro, of course, we are doing it, but hydro is always, although it is now classified as renewable, but we have to look at the environmental aspects of it. And as for wind energy is not practical in Malaysia, except for certain like coastal regions or islands where we can. And to enhance the wind energy, again, requires a lot of input from electrical engineers. So electrical engineers are involved in all these various elements of energy, right from the electricity, which of course is now generated by fossil fuels, and of course to improve the energy from the renewables.
Yeah, yeah, definitely. Engineers have a lot of roles to play. But what role do I mean? What attribute do you think that an engineer should have? I mean, for them to to thrive in this energy sector. What sort of character? What sort of attribute that do you think that they need to have to really advance in this career? Yeah.
Yeah. I think the main attribute is that they should realize that a lot of things depend on energy. Energy is actually part of a good part of our working life, right? And we need and we use energy everywhere, right? At home, in offices, in buildings, industry, and so on. And we need the industries, of course, to supply our food and all that. So the attitude or the aptitude they should have is that there needs to be a certain liking or certain discern towards, like, I want to do something to improve the energy situation in whatever it is, whether your home or whether your industry or office. There has to be a certain amount of enhancement in the use of energy. And so, and the basic things actually you already taught in your electrical energy course, right? So you want to use that, so there's a need to use that in the field to do the research and development. Of course, once we do now currently is only the maintenance part of it, right? Many engineers look at the maintenance part, but I think the engineer should go a bit further than that. Not only maintenance, but also how to sort of enhance the utilization of this energy. Of course, in the power sector, you have the generation and so on. And then, of course, the generation can come from other sources of energy. Right?
Okay. Yeah, I think to sum it up is that I think as an engineer, right, if you want to be a good engineer, you need to be curious and you need to be
realize that energy is an important part.
Yeah, solution driven, right? So you need to be creative as well to look for solutions to address these energy issues as well. And of course, first of all, you need to have the passion, right?
Yeah, passion.
Yeah, without the passion, I think you really can't go far. Okay, I think we are almost reaching the end point, but so we want to go back to our first point here is that just now, Prof, you define what is an energy management and who is an energy manager. So now maybe we would like to understand further, like what would be the prospect? I mean, for as an energy manager in Malaysia, what maybe you can comment a little bit on that.
Okay. Now, energy manager currently is just a post in any industry or organization, but now it is going to become a necessity by law, right? That is, we are going to actually develop, or in fact, it's almost done, the Energy Efficiency Act, where actually it's called the Energy Efficiency and Conservation Act, but I never like the word conservation. So in the Energy Efficiency Act, so they are going to mandate that all industries and buildings actually really have to manage the energy well. And to manage this, they need registered energy managers. So an energy manager is someone who really looks into that. So his role is not the production or the other things and all. Maintenance is different. He looks into the how the energy is utilized in the organization and how it can be used better, or how the ways to use the energy in a more what should I say, efficient way. Right? So energy managers are people who are required both in the building sector and the industry sector to help the whole organization manage their energy well. And as I said now, since it's going to be mandated, we really need a pool of energy managers who are able to sort of, and for the energy managers, they require, of course, electrical energy is, electrical engineering is a very important tool. You need to be good at your engineering in the electrical, your power systems and all that, as well as, of course, mechanical engineers. Now, even mechanical, when you talk about the air conditioning and so on, is still the power comes from electricity, right? Electricity, the compressor, the pumps, and so on. So these are the items where the energy manager has to focus. So in the future, I think slowly now the energy manager will be playing a very important role in this energy industry. And once it is mandated under the Act, I think the scope of energy manager will be very wide. So the industries will actually have to look for people and appoint them as energy managers with role of doing this thing of looking into ways to improve the energy consumption in the industrial organization. And we always say that energy manager is actually part of a team, right? A team of people looking into the ways to reduce the energy consumption. Again, keeping the production, the safety, and the output unaffected. It's very important.
Yep. And Prof, any advice on how to be a good energy manager?
To be a good energy manager, you have to be, one is knowledgeable. I think knowledge is very important. Then the other thing is you have to keep abreast of the various technologies which are coming, right? You find that every time there is new technology, right? You have a motor, in 5 years' time, there's a more efficient motor, right? And then there's much more efficient motor and so on. So when you find that there is a fault, right, now you say, oh, my motor is faulty, okay, replace by another motor. But now you have to say, replace by a more energy efficient motor, right? So that is where the energy manager comes in to say that his role is actually played by that. And then, of course, the other one is the economical factor. Say, oh, you replace by energy efficient motor, you have to pay more. Say, yeah, you pay more in the beginning, but in the long run, you gain. Right? So then comes your cost analysis and so on, the life cycle cost. So that's where the energy manager has to be play a prudent part in the managing the energy. And he is actually thinking of new technologies, which are of course more expensive, but which will pay in the long run, and how to put this into the so-called place.
And I guess the skill of communicating, conveying this message.
Of course, that is all.
Yeah.
That is all there, because you are an energy manager, but you're not the manager of the of the organization. So you have to convince your management, and that's why we say that when you practice energy management, it has to be right from the top to the bottom, so that even the so-called personnel, the management, technical personnel, also know about the consequences of them being careful and also prudent in the use of energy.
Yeah, Prof, just now you mentioned that the act is almost passed or something, right?
Yeah, it's almost done. Yeah.
Yeah. So once it is done, do you foresee that there will be a shortage of energy managers in the field?
Yeah, because currently we are training energy managers, but we are training energy managers now mainly in the field of electrical. But in the Act, it covers electrical and thermal. But whatever it is, the Act always says that you have to be an electrical energy manager first, and then you move on to the thermal part. So therefore, there is going to be a lot of opportunities for electrical energy managers. Right? And it is not a difficult role to play, but it is really a challenging role. I should say it's a challenging role, so that you show that you can achieve some substantial savings.
Right. So there you go. And perhaps, Prof, you can also, because we have been talking about electrical energy, and electrical energy.
Yeah.
So maybe you can shed a little bit of light on thermal energy, because now the Act will be taking into consideration the thermal part as well. So maybe you can,
Sure.
explain a little bit. Yeah.
Now, thermal part actually involves things like air conditioners, boilers, furnaces, and all these things, which still do require the energy, electrical energy, but they are different applications, right? Like for example, a boiler uses fuel, right? But it still uses a burner, right? Powered by electricity and so on. And then we have furnaces, large furnaces, which a lot of heat is required, and that is normally got by also from oil, from fossil fuels. But then there is also the electrical part to it. So this appliances, and then we have the air conditioner, we have the cogeneration now, right, which shows that you can generate your energy, but you can use it both for electricity and also heating, right? So these are the things. So the thermal energy is actually an extension of the electrical energy usage. So that's why I said that even in the Act, it is promoted that you do the electrical energy management first, then you move on to thermal.
Understood. Yeah, Prof. Perhaps almost at the end, maybe Prof, you can also mention a little bit like, so if I want to be an energy manager, right? So what are the routes that I can consider?
Of course, the route is first you have to get a degree. You need an electrical engineering degree. And then the other route is you have to spend at least 1 or 2 years in the industry or an organization, a building also can, doing some technologies in energy management. Right? And then you have to appear for an interview with the Energy Commission. But at the same time, it's also good to attend courses given by practitioners. I mean, which is knowledge outside your textbook. So the practitioners will have some like in-kind knowledge, the real knowledge in the field. And that knowledge will be useful for you. So with all that knowledge, you then appear for an interview with the Energy Commission. You must be familiar with all the regulations and the Act and so on. And that will equip you to be a good energy manager.
Right. So perhaps it's almost 12. Maybe one very last question, and a very important question is that it's not a question, but more like, Prof, if you were to give one advice to any students, who aspire to become an electrical engineer, so what would be that advice?
Now the advice is again, electrical engineering is very wide application, very challenging, and in electrical engineering, again, we have the one part which is electronics. And electronics is something which you should have a passion for, because every appliance is now using electronics. And electronics is used in various fields now. All the instrumentation and things are all electronics. Even if you go into medical, everything is now electronics. So therefore, you need a passion for electronics in the electrical. Electrical. And once you have that, I think you can really enter into an area which is very widespread. Electronics is, I think, is a major thing. And of course, with the electronics come the digitalization and the IT and so on. Everything related to electrical engineering. So you enter the field, and then later on you see which area you want to focus on.
Yeah, I think that is a very good way to, I think, wrap up our session for today. And I think it has been our pleasure to have Prof. Kanan with us on board for close to 1 hour and to shed some insights into what is energy, what is energy management, what is renewable energy, what can electrical engineer do in that, and it's such a wide and diverse
It is
area.
wide.
So I do encourage to those of you who have watched this video, please replay it a few times to really grasp the essence of this, and hope that any aspiring students who would like to join engineering, you can hit some of the advices that Prof. Kanan has shared with all of us. So with that, I think on behalf of the Faculty of Engineering, Multimedia University, we would like to really thank you, Prof. Kanan, for your time and for your wisdom and your experience sharing with all of us. And we hope to see you again in our future webinar. Thank you, Prof. Kanan.
Okay, thank you. And my slides, if you want, you can send it to those people who attended the authorities. I mean, I leave it to you now.
Thank you, Prof. Sure.
Because at least they'll have it's just a background, it's nothing very different. But of course, what we spoke is much more. Huh?
Yeah, sure. Thank you so much, Prof. Kanan.
Right.
Thank you.
All right.
Goodbye.
Bye. I can leave, huh?
Yes.